Okay, here we go. My first time recording at home. All right, I had several people asking me to make some videos of some of these assignments. So, again, feel free to ask me questions and stuff. I'm trying to get back to people as soon as I can. I do need to make sure that you're checking in periodically, so make sure that you are contacting me somehow. Yeah, that's really important. So, I'm going to work through the practice for the Mod 21 quiz. So starting off, use the 68, 95, 99.7 rule to calculate the probability. Now, first thing I'm going to do is I'm going to go ahead and draw myself. Let's see, is it clear at all? Let's see, it's focusing. Apparently I can't draw straight lines, but that's okay. So there's my bell curve, and we know that we put in the middle, we put the mean. Does it say that the mean? It doesn't give us values actually, so I'm just going to split it up. I do 3 lines on the right, and then I do 3 lines on the left. And again, the middle two are 34%. Next one is not 3, it's 13.5%. And then 2.35%. And then finally 0.15%. And having those all together should add up to 100%, not 180. Sorry, my other class is doing triangles. So let's, I can mute my thing. There's no pause button on this one. Interesting. Okay, well, I hope I have those percentages right. I'm pretty sure. Let me just verify. So let's see. 0.15 plus 2.35 plus 13.5 plus 34 is 50. Yeah, we should be good. Okay. So let's go ahead and check now. This again is the mean. So I'm going to label this X bar, or sometimes it's labeled with that other symbol, the mu. This would be plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations. This would be minus 1 standard deviation, minus 2 standard deviations, and minus 3 standard deviations. So the probability that a number is less than, that means to the left of, 3 standard deviations below the mean. Well, this is 3 standard deviations below the mean. This line right here, left of there is 0.15%. So there is my percentage. What's the probability that a number is greater than? That means to the right. Remember, this is ultimately a number line. So anything to the left is less than, right is greater than. 2 standard deviations above the mean. So 2 standard deviations would be right here. Greater than would be to the right. So I need to add 2.35 and 0.15. Plus 0.15 is equal to 2.5%. That's the probability that a number is greater than 2 standard deviations above the mean. The probability that a number is between 1 and 3 standard deviations, between, is interesting. So between 1 and 3 standard deviations below the mean. So in other words, 1 standard deviation below the mean and 3 standard deviations below the mean. Okay? Now, keep in mind, so we're trying to autofocus here, that it's a little bit different when you have a z-score. It's a little bit different. I think there might be a problem like that a little bit later. But right here, I just need to add the 13.5 plus 2.35. 13.5 plus 2.35. And that gets me 15.85%. Right there. Okay. All right. Birth weights in a population are normally distributed with a mean of 109 ounces and a standard deviation of 13 ounces. So here's what I'm going to do. I'm going to take my same one and I'm going to add this information to it. So the mean is 109 and the standard deviation is 13. So I'm going to do 109 plus 13. That gives me 122 plus another 13, and that's 135, and plus another 13 is 148. Now I'm going to do the other side. So I go back to the 109 and this time I'm subtracting 13. So this is 96 minus 13 again is 83, and one more time is 70. So Sarah was 122 ounces. Now, do you notice that 122 ounces is exactly one of my lines right there? Her z-score should be what? If this is my mean, my mu, or my x-bar, this should be one standard deviation above, right? So how do I find a z-score? I take the number minus the mean divided by the standard deviation. So 122 minus 109 divided by standard deviation is 13, not 12. And I do get 1. So her z-score is 1. What percent of all birth weights would you expect to be lighter than 122 ounces? Well, if I'm looking here, I would expect this plus this plus this plus this plus this. I would expect 84% to be lighter than that. Now, since it made me go to the z-score table, let's go see what a z-score of 1 says. Because remember, a z-score of 1 gives me that percentage to the left. So 1.0, 84.13%. That's from the z-score table. This is from the bell curve. The z-score table, keep in mind, is more accurate than the curve. Is just it's a good enough approximation that people are okay with using it when you have those nice values. Okay. Number 6, what percent of all birth weights would you expect to be heavier than 122 ounces? Well, when we use our z-scores and we get this number, this 84.13, that's telling us everything lighter than or less than. If I want to know heavier than or greater than, I need to find this side of the curve, which means I take 100% and I subtract whatever this is. Or if I want to think about it on the bell curve, I'm not adding up all of these, I'm adding up the other side because that would be the greater than side. So that would be 2.35 plus 0.15, which is 2.5%. That's what you get if you use the 84% off the chart or off the bell curve. If you use the z-score, you would do 100% minus 84.13, and that, hang on, I did something wrong. Oh, I forgot to add, sorry, it's 13.5 plus 2.35 plus 0.15. So 13.5 plus, let's see, that gives me 16% there. Or if I do the 100% minus 84.13, that gives me 15.87%. So again, I would have to specify which way I want you to go, whether I want you to use the bell curve or I want you to use the z-score table, but you can see that they're very close. 15.87 and 16%, very, very similar. Okay. All right. If we consider usual weights to be those with z-scores between 2 and -2, was Sarah's birth weight usual or unusual? Well, what was her z-score? Her z-score was 1. Is 1 between 2 and -2? Yeah. So if we're saying that between 2 standard deviations above and 2 standard deviations below, that those are considered, or that's considered the range for normal birth weights. Is she in that range? Yes. She's right there. She fits within that normal range. Now, if somebody had a birth weight of 65 ounces, down here, that's definitely outside that range. So we would not consider that. Let me make sure that you understand that. If I were to highlight that range from the mean 2 below to 2 above, meaning anything that falls in here is normal. So any weights between 83 and 135 would be considered normal because they convert to a z-score that fits within that -2 to +2 range. Any of the weights outside of there would convert to a z-score that's not in that range, meaning it would not be normal. Okay, so is her birth weight usual? Yes, because her z-score of 1 is within the usual weight interval of -2 to +2. Okay? All right, I had some people ask me questions about 8 through 13 that they were stuck on this. And you're going to kick yourself when you see how easy it is. It says, use a standard normal table to calculate the following probabilities. I want to know when z is less than 1.21. Remember, your graph or your numbers off your chart always give you less than. So if it's less than, I just take it straight off the chart. If it's greater than, that's when it's asking for this side, and I have to do 100% minus what I get off the chart. So this one starts off with less than. That makes it look like less than or equal to. So z is less than 1.21. So I'm going to find 1.201. That's 88.69. 88.69%. That's all it's asking for. Now, z is greater than 1.21. Well, this was less than, so if 88.69% is the probability that it's less than that number, the probability greater than would be the other side, or 100 minus 88.69, which gives me what? 11.31%. Okay, so if it's less than, you just take it straight off the table. If it's greater than, you have to do 100% minus what's off the table, because that's what gets you to the right. Then we have z is between -2 and 0.38. Okay, well, let's see. -2 on my z-score table would be -2.0, 2.00, 0.0228, 0.228, and then 0.38, that's a positive 0.38, 0.3012345678 is 0.6480. And whenever it does between, you always do the bigger one. Let's do percentages, it's easier. 64.8%. And this would be 2.28%. Whenever it says between, you always do the bigger one minus the smaller one. So 64.8 minus 2.28 gives me 62.52%. And the reason is, when it says between those two things, I want you to think about the idea of being between something. If I have my number line here, and I'm looking for between, let's see, that example was -2, and here, let's go ahead and just draw a hypothetical here, and 0.38. Well, if I go get the 0.38 percentage off the chart or off the z-score table, it's going to give me a number that represents everything lower than 0.38, right? Isn't that what it means when I get the percentage off the z-score table? It's telling me what percentage of the curve is to the left of 0.8. if I want to know between -2 and 0.38, I need to cut off this part so that I'm left with just what's between. Well, what is this part? Well, it's the z-score, or the z value that you get off the table from -2, because when you go look at -2, doesn't it tell you that percentage? So in other words, when I got -2 off the table, I got 2.28%. So this section right here is 2.28%. Okay? When I got the 0.38 section, that was 64.8, meaning this whole thing together is 64.8%. So to do the between one, I take the big section and I subtract that part, and the remaining part will be that between portion. So that's what you do when it says between. Okay? All right, z is greater than 2.58. Greater than. Again, I have to do the 100% minus, because greater than is asking about to the right of the curve, and the chart gives me to the left of the curve. So the negative side, -2.58, sorry, -2.58, let's see, 0.0049, that's 0.49%. That's a tiny, tiny percentage. Should kind of make sense though. 2.5, almost 2 and more than 2.5 standard deviations below. That's going to be a teeny tiny percentage, right? Because 1, 2, it's like right in here. It's going to be a small percentage. So 0.49 would be 99 point what? 51%. That should be my answer there. Okay, less than, I like the less than ones because they're straight off the chart. -3.2, -3.2, so that's, move my decimal 2 places, 0.07%. It's an even smaller percent. Okay. All right, again, I don't subtract when it's less than, I do subtract from 100 when it's greater than. And then finally, between 3.1 and 1.28. So again, I'm going to find these values, and then I'm going to subtract the bigger one minus the smaller one. So 3.1, that would be 3.10, that's 99.9%. 99.9%. And 1.28 is 89.97%. So if I subtract bigger minus smaller, 99.9 minus 89.97 gives me 9.93%. That's the probability that it's between those. Okay. All right, this one's just a vocabulary one. Each phrase, we just want to know, does it mean that it's greater than or less than? So if you see something that says it is at least 5, that means that x is less than or equal to, no, x is greater than or equal to 5. It means the smallest number x could be is 5, but most likely it's going to be greater than. For example, if you have school for at least 5 hours a day, that means the very least amount of school that you could be attending is 5 hours. So it's going to be more than 5 hours. At most would be the opposite. That means it's going to be less than or equal to 5. Taller than 5 would be greater than 5. By the way, taller than does not mean at least as tall as. Taller than is simply the greater than. It's not the greater than or equal to. Shorter than would be less than 5. Lighter than 5 would be less than 5. Over 5 would be greater than 5. 5 is less than x is less than 7. Could be written as between 5 and 7. Could be written like this one. It would say the interval from 5 to 7. When it says between 5 and 7, it's technically not including 5 or 7. But if you have the or equals to, meaning it's including the 5 and the 7, it could be said that it's the interval from 5 to 7, and that shows that it's included. There's no real difference in the calculation of less than versus less than or equal to. When we're talking about the z-chart, we're not worried about the difference between less than or equal to and just less than. We'll treat them the same for the time being. Okay, I hope that answers some questions for you. Again, post back if you have more questions. All right, happy studying.